We will begin by creating a new circuit. Changing the file name. For our components, we'll make use of a microbit with a breakout. We'll once again use a breadboard, and the small breadboard will be sufficient. We will once again require a resistor and an LED. What the breakout permits us is the ability to readily connect not just the main pins of a microbit, but also all the smaller pins that are available. You'll see that it's showing us the ground connections are 3-volt power, and there are primary pins of 0, 1, and 2. And then we also have all of these additional 3 through 20. Our resistor, we will set the resistance to 47 ohms, and I will rotate that. Let's bring it down closer, and my LED closer so I can zoom in a bit so we can see this more readily. We will need to connect our ground to our breadboard, and that way we won't have to connect the circuits directly to power or to the microbit. We'll use the resistor and just put it here. I will need to rotate I will place my LED onto the breadboard. Now for wiring, I will make use of pin 1, and I'm going to have my wire travel from pin 1 into my resistor, and then I will have this travel back to ground. So what this gives me is the ability to send electrons through my circuit, through my LED, and back to my microbit when I choose to do so using code. So let's get to the code. I'll make use of a forever loop, and I'll need to have a variable. I'll create my variable, and I will call it light state. So my state of my light can either be on or it can be off. I'll make use of an if-else statement. So what that gives me the ability to do is make a statement that if something is occurring, then do something. Otherwise, do this other thing. So for the logic I want here, I'll need some math. And I'm going to use an equal statement. So I'll go back to my variable and say that if my light state is equal to 0, then I will, so if that's true, I'm going to set my light to 1. Else, oh, and then I'll just put in a pause. Else, I'll set my variable to 0 and wait 1 second. Consider a variable just an assigned value. So it's saying if this assigned value is 0, then change it to 1, then wait. But if it wasn't 0, then set it to 0 and wait 1 second. I'll need a second forever loop. And within that, I once again will make use of a if then else logic. grab up math. Light state. So what we're saying here, so in our first statement, it was constantly turning the light state variable from 0 to 1 with a 1 second interval in between. So now it's saying if the light state is equal to 1, then I want to turn on the LED. So this is an output. So that means that I need to write to my pin. So we're going to our analog pin number 1. And we're going to turn it on. A 1 is on. And otherwise, if the light state was equal to 0, we would have that pin 0 or off. Another way this is sometimes done is through the word high for 1 and low for 0. In Tinkercad, it's zeros and ones. So now we've got the code. I could take a screenshot of that to save for use later. But now I'm going to just close the code so I don't have to look at that. And I'll start my simulation. And there, lights on, lights off. Light is on, light is off for 1 second in between each of those. And this will go forever. So that's how we're able to get a light to turn on and off using a bit of code.